NVM Express, NVMe, or Non-Volatile Memory Host Controller Interface Specification, is a specification for accessing solid-state drives attached through the PCI Express bus. NVM stands as an initialism for non-volatile memory, which is used in SSDs. As a logical device interface, NVM Express has been designed from the ground up, capitalizing on the low latency and parallelism of PCI Express SSDs, and mirroring the parallelism of contemporary CPUs, platforms and applications. By allowing parallelism levels offered by SSDs to be fully utilized by hosts' hardware and software, NVM Express brings various performance improvements. NVM Express SSDs exist both in form of standard-sized PCI Express expansion cards and as 2.5-inch drives that provide a 4-lane PCI Express interface through the U2 connector. SATA Express storage devices and the M2 specification for internally mounted computer expansion cards also support NVM Express as the logical device interface. Background. Historically, most SSDs used buses such as SATA, SAS or fiber channel for interfacing with the rest of a computer system. Since SSDs became available in mass markets, SATA has become the most typical way for connecting SSDs in personal computers. However, SATA was designed primarily for interfacing with mechanical hard disk drives, and has become increasingly inadequate as SSDs had improved. For example, unlike hard disk drives, some SSDs are limited by the maximum throughput of SATA. High-end SSDs had been made using the PCI Express bus before NVMe, but using non-standard specification interfaces. By standardizing the interface of SSDs, operating systems only need one driver to work with all SSDs adhering to the specification. It also means that each SSD manufacturer does not have to use additional resources to design specific interface drivers. This is similar to how USB mass storage devices are built to follow the USB mass storage device class specification and work with all computers, with no per-device drivers needed. As of September 2014, a new standard for using NVMe over fiber channel is also in development. History. The first details of a new standard for accessing non-volatile memory emerged at the Intel Developer Forum 2007, when NVM HCI was shown as the host-side protocol of a proposed architectural design that had ONFI on the memory chip side. An NVM HCI working group led by Intel was formed that year. The NVM HCI 1.0 specification was completed in April 2008 and released on Intel's website. Technical work on NVMe began in the second half of 2009. The NVMe specifications were developed by the NVM Express Workgroup, which consists of more than 90 companies. Amber Huffman of Intel was the working group's chair. Version 1.0 of the specification was released on March 1, 2011, while version 1.1 of the specification was released on October 11, 2012. Major features added in version 1.1 are multipath I/O and arbitrary length scatter-gather I/O. It is expected that future revisions will significantly enhance namespace management. Because of its feature focus, NVMe 1.1 was initially called Enterprise NVM HCI. An update for the base NVMe specification, called version 1.0e, was released in January 2013. In June 2011, a promoter group led by 7 companies was formed. The first commercially available NVMe chipsets were released by Integrated Device Technology in August 2012. The first NVMe drive, Samsung's XS1715 Enterprise Drive, was announced in July 2013. According to Samsung, this drive supported 3 GB per second read speeds, 6 times faster than their previous enterprise offerings. The LSI SanForce SF3700 controller family, released in November 2013, also supports NVMe. Sample engineering boards with the PCI Express 2.0a, 4 model of this controller found 1800 MB per second read-write sequential speeds and 150K/80K random IOPS. a Kingston HyperX prosumer product using this controller was showcased at the Consumer Electronics Show 2014 and promised similar performance. In June 2014, Intel announced their first NVM Express products, the Intel SSD data center family that interfaces with the host through PCI Express bus, which includes the DCP3700 series, the DCP3600 series, and the DCP3500 series. As of November 2014, NVMe drives are commercially available. In March 2014, the group incorporated to become NVM Express, Incorporated, which as of November 2014 consists of more than 65 companies from across the industry. NVM Express specifications are owned and maintained by NVM Express, Incorporated, which also promotes industry awareness of NVM Express as an industry-wide standard. NVM Express, Incorporated is directed by a 13-member board of directors selected by the promoter group, which includes Avago Technologies, Cisco, Dell, Inc., HGST, Intel, Micron, NetApp, Oracle, PMC, Samsung, SanDisk and Seagate. Comparison with AHCI. The Advanced Host Controller interface comes with the benefit of wide software compatibility, but as a downside does not deliver optimal performance when used with SSDs connected via the PCI Express bus. As a logical interface, AHCI was developed back at the time when the purpose of a host bus adapter in a system was to connect the CPU memory subsystem with a much slower storage subsystem based on rotating magnetic media. As a result, AHCI introduces certain inefficiencies when used with SSD devices, which behave much more like DRAM than like spinning media. The NVMe device interface has been designed from the ground up, capitalizing on the low latency and parallelism of PCI Express SSDs, and complementing the parallelism of contemporary CPUs, platforms and applications. At a high level, the basic advantages of NVMe over AHCI relate to its ability to exploit parallelism in host hardware and software, manifested by the differences in command queue depths, efficiency of interrupt processing, the number of uncallable register accesses, etc., resulting in various performance improvements. The table below summarizes high-level differences between the NVMe and AHCI logical device interfaces. Operating system support. Windows. The NVMe Windows Working Group is an initiative from the Open Fabrics Alliance to maintain software for Microsoft Windows to use PCI Express solid-state devices. The baseline Windows driver contributed to the open source initiative was developed by several promoter companies in the NVMe workgroup, specifically IDT, Intel, and LSI. Microsoft added native support for NVMe to Windows 8.1 and Windows Server 2012 R2. Native drivers for Windows 7 and Windows Server 2008 R2 have been added in updates. Linux. Intel published an NVM Express driver for Linux. It was merged into the Linux kernel mainline on March 19, 2012, with the release of version 3.3 of the Linux kernel. A scalable block layer for high-performance SSD storage, known as BLK Multica or BLK-MQ and developed primarily by Fusion IO engineers, was merged into the Linux kernel mainline in kernel version 3.13, released on January 19, 2014. This leverages the performance offered by SSDs and NVM Express, by allowing much higher I/O submission rates. With this new design of the Linux kernel block layer, internal queues are split into two levels, thus removing bottlenecks and allowing much higher levels of I/O parallelization. As of version 4.0 of the Linux kernel, released on April 12, 2015, Byte I/O block driver, the SCSI layer, loop device driver, unsorted block images driver and RBD driver have been modified to actually use this new interface. Other drivers will be ported in the following releases. Freebsd. Intel sponsored a NVM Express driver for FreeBSD's head and stable/9 branches. The NVD4 and NVMe4 drivers are included in the generic kernel configuration by default since FreeBSD version 10.2. Solaris received support for NVMe in Oracle Solaris 11.2. OpenBSD. Development work required to support NVMe in OpenBSD has been started in April 2014 by a senior developer formerly responsible for USB 2.0 and AHCI support. Chrome OS, on February 24, 2015, support for booting from NVM Express devices was added to Chrome OS, X. In the 10.10.3 update for OS X Yosemite, Apple introduced support for NVM Express. The new Retina MacBook uses NVMe as the logical device interface. Software support, QEMU. NVMe is supported by QEMU since version 1.6 released on August 15, 2013. UEFI, an open-source NVMe driver for UEFI is available on SourceForge. References. External links, official website, LFCS, Preparing Linux for Non-Volatile Memory Devices, LWN.net, April 19, 2013, by Jonathan Corbett, Multipathing PCI Express Storage, Linux Foundation, March 12, 2015, by Keith Bush.